Okay, so in this video, we will wire up a very simple light emitting diode LED and see it light up. So here is a circuit diagram of what we want to do. So this power and ground could be two sides of a battery. So positive side of the battery, the negative side of the battery, or in our case, we'll use a 5 volt and the 0 volt or the ground from the Arduino board. This is the resistor and that's my LED right here. So that's just a block diagram. Actual diagram of how we would draw as an electrical schematic is right here. So here's the 5 volt I'm going to connect to on the 5 volt side of my SparkFun Breadboard or the Arduino. Here is my resistor. The value of this resistor can be 270 to 470 ohms. Basically, a resistor limits the amount of current flowing through this LEDs. The more current flows through this LED, the brighter it glows, but the LEDs are rated only for so much amount of current. If we pass too much current through the LED, they will burn out. So in that case, we have 5 volt supplying the current. Current flows through here, through the LED, goes back to ground, and the LED will light up. So that is the circuit we want to wire up. So let's get started. So I plugged in 5 volt, the red wire, to the 5 volt pin. So that's 1, 2, 3, fourth pin from the bottom right here on the red board. And I've connected the black wire to the ground. And what I'm going to do is bring that ground, the black wire, the other end of it, and put it on the black power line right here. And I'm going to bring the red and put it on the red power line of my breadboard. So now I've connected 5 volts and ground to this particular row. What we will do next is uh, make this connection from the 5 volt side through a 330 ohm resistor. So I'll put in a 330 ohm resistor. I have a resistor pack, very simple resistor pack here with 330 ohms in it. Uh, You'll notice that the resistors are color coded. The colors actually mean something. So I'm going to connect one end of that resistor right here to the 5 volts. The other end of the resistor will go into one of the rows. So I'm connecting to row 2, column D. So here's my resistor right here, row 2, column D. Okay. What I'm going to do next is open up my pack of LEDs. So here's my pack of LEDs. So on the LED side, what we'll see is, so here's the LED that I pulled out of my pack. You'll see one of the legs is longer than the other one. Also, if I just feel the LED, what I'll find is there's a flat side right here. So the flat side exists on one side and the rounded end exists on the other side. On the circuit schematic of an LED, you notice this bar right here. So the flat end, that's the flat end. It's basically saying current. You can look at the schematic of the LED. It almost looks like an arrow. This arrow basically shows that the current can pass this way, but current trying to go this way gets blocked by this wall or the flat end. So what we'll do is basically wire the LED in this way. So the non-flat end or the rounded end will go towards the resistor. Okay, so I'm going to connect my non-rounded end to row 2 because that's where the resistor was connected to. The resistor is connected to 2D. I'm now connecting to 2E, and the other end of this wire is going to go to ground. Okay, to ground. All right, so I have the circuit wired up exactly as such. What that means is now if I connect the power to this, so let me connect the USB cable to the breadboard, make sure it doesn't shift. I should see the LED light up. So as soon as I connected it, this LED received power, so the current started flowing from the plus side right here on the through the resistor, through the LED, lit up the LED, and went back to ground, creating a circuit loop. Okay, so this is how you create a very simple circuit on a breadboard. Next video, we'll see how to wire up a very simple push button switch.